All right, how's it going, y'all? So today I'm really excited because this is a video I've been planning out for a long time. And this video is going to cover how to pretty much take anybody who's never really done anything with a Raspberry Pi before and get them to a place where they are comfortable with Linux. They can set up any Linux service, at least get their way through it and figure out their way to actually using Linux. And so my goal for this is to lay out 5 different projects. All of these projects are actually going to be very useful things that are fun to use and actually useful around the house. So there's going to be 5 different projects, starting from I've literally never heard of a Raspberry Pi, I've never used Linux before, I have no idea what I'm doing, all the way up to you need me to do something in Linux? I might not know exactly how to do it, but I can figure out my way through it. And that is really how this video is going to be structured. This video is going to be essentially prompts for 5 different tasks that you need to use a Raspberry Pi to complete. These are 5 different services to stand up and things like that every single one of them is going to be designed to kind of teach you a different skill and build up upon that. And then finally, the last one, if you are able to set it up, I will say you pretty much can throw Linux on your resume because you're pretty much going to be comfortable running around inside of Linux. It's very useful. So all 5 of these tasks are set up with Raspberry Pis in mind, just because they're phenomenal training resources. They are cheap computers that are able to very quickly be flashed to a brand new operating system like that. And so it makes it really easy and not very difficult to experiment because you know, okay, if I mess up, a flash only takes 5 minutes. And so that way you feel a lot more comfortable just ripping everything apart and saying, you know what, we're gonna restart this and we're going to do it right. Versus standard Ubuntu installs and stuff like that on a different machine can take a while unless you're comfortable setting up virtual machines. But if you're comfortable setting up virtual machines and cloning them, you're probably going to skip towards the end of these tutorial series anyway. And so my goal for this is every single one of these projects should be 2 things. One, it should actually be useful. It's not just setting something up for the sake of setting something up. It's actually going to be setting something up to get you more comfortable with Linux and also having something useful at the end of it. And then 2, it also should actually kind of teach you a skill and build upon that. And so that's my goal for this. So one other thing before I get into this, I do want to say, the majority of these, you can just download scripts that will run these. For example, if you wanted to run a Nextcloud box, there's a script for it that'll just build you a Raspberry Pi Nextcloud box. The sake of these tutorials is to teach you how to figure all this stuff out. So I would really recommend not actually just doing a script, but instead actually for all of these downloading the packages and setting them up yourself, because that is how you learn. You'll also see I have notes with me. I have prepared all of this, and it's something I've been thinking about for a really long time, and so I'm excited to finally get started with this. All right, and so essentially all you're gonna need to do every single one of these tasks is pretty much 2 Raspberry Pis, 2 micro SD cards, and 2 flash drives. That is all that's gonna be required for all of these, and obviously the power supplies as well, and network cables. All right, and so the very first one is going to be for people who have absolutely no idea what they're doing, and this is the first time they've ever used a Raspberry Pi before in their life, and that is just going to be install either HomeBridge or HomeAssitant on one of these things. It is very easy to do. All you need to do is go ahead and download the Raspberry Pi imager and flash one of those 2 operating systems onto a micro SD card. Then just plug it in the Pi and boot it up, and you will have the instance. That's just to get people comfortable flashing something. So HomeBridge is used to bring pretty much any smart device into an Apple HomeKit. So if you don't have any Apple devices or any smart devices at all, probably not useful for you. If you don't have any smart devices at all in your house, HomeBridge and HomeAssitant are not really going to be useful for you at all. And so you can build a RetroPi if you want to. These are just things to go ahead and get you comfortable with it. Another thing you're going to want to do for all 3 of these, whichever one you choose, is to go through and actually set up your router to hand it a static IP address, what's called a DHCP reservation. So every single time the Pi boots up and talks to your network, it will receive the same IP address every single time. So my goal for this is to get people comfortable just connecting to the Pi and realizing the Pi can run all these services. And so like if you need to use a custom port in your browser, those kinds of things come up, and just getting everybody somewhat comfortable with that. There's not going to be any kind of command line stuff for these to start, but that's going to be in the next tutorial. Finally, for a bonus, set up a USB flash drive to automatically back up your entire configuration every single night. So that is a little bit more advanced, and it's probably actually skipping into the next ones. But that's just an easy place to start where it's, hey, get comfortable with all these things. All right, so now on to number 2. Number 2 is going to be a big step up because now we're going to be starting doing command line things. But because of this, I'm actually going to be using a tutorial I've already done on this. And kind of, this is one of the ones where you can just straight follow a tutorial just to kind of get comfortable. And so this is going to be setting up a Raspberry Pi as an SMB server. SMB servers are super useful because it allows you to use your Raspberry Pi as a local file server for all the different PCs on your network. PC, Mac, or Linux can all talk to an SMB server, and so that way you can use this as a NAS. And so this is going to be a big step up from the last task where you're just kind of getting started, but this is where you're jumping in the water. This is where you're going to get comfortable using SSH because you're going to be SSHing into the Raspberry Pi itself. Then you're going to be also using command line to actually edit some files and create files. And then you're also going to be using Package Manager to install different packages. This is going to be a large part of what Linux is, especially when you're setting up a Linux server from command line. And so follow that tutorial. I actually did a big Raspberry Pi series actually to start this channel that all those things together will get you started there. But this definitely is going to be the biggest step up. And so if people are interested, I will actually remake that entire tutorial starting from I've just flashing an image all the way up to having a Pi built, just because following somebody for this step is totally okay, just because it is so much more complicated than other ones. This is going to be by far your biggest step up in terms of difficulty, just because now you're actually managing services and things like that. All right, and so the goal for the end of this is for you to have an SMB server on your network that you can actually save files to from any computer. And you can even have different logins for different computers and everything like that. And so this is a really useful thing, and it's actually a lot of fun to set up. This one actually kind of has 3 different bonus parts to it because there's a lot here. And so the very first one is set up it using a USB flash drive. Don't actually have the SMB share stored on the micro SD card, but instead have it stored on a flash drive. And so that should be pretty straightforward. And I believe I actually go over how to do that in the video, but essentially you'll be mounting it on boot and everything like that. And so it's very useful to learn those skills. Then the next one is actually really useful as well. And it's actually use it for a print server. So SAMBA can also be used as a print server. And so what this means is you'll be able to plug in a USB printer to one of the USB ports on the Raspberry Pi. And from any computer on your network, you'll be able to print jobs to this printer. And so it's really useful. And for $35, having this always connected to your printer and having wireless print is pretty cost effective compared to other kits out there. And so that is the second bonus. And finally, the third bonus is for people who are already kind of gurus at this stuff and really just wanting fun projects to like kind of expand out their knowledge. And that's actually going to be using BTRFS on the flash drive for the file server. And so you'll want to set up BTRFS snapshots on the flash drive. And so that way, if there's an error, you can roll back to previous snapshots. But that is going to be for much more advanced users. And that's a very much a high flying bonus. All right, and so now on to number 3. Number 3 is set up a Raspberry Pi as a DNS bind server. So don't just go ahead and download Pi-hole on this thing. No, actually go through and set up bind DNS because it is a great way to learn services, SSH, and also configuring different things. DNS is a crucial part of pretty much any network. And so by learning DNS in this way, it is very useful. Going through and doing this is going to be much more of, I don't have a tutorial on how to do this yet. And so it's just going to be go forth and figure out how to do it. Essentially what you want to have at the end of this is you want to have a Raspberry Pi that if you send it a DNS request, it will do what's called a forwarding DNS server. And so what will essentially happen is your computer will say, hey, I need to get to this server. I want to go to www.google.com. Where is that? And what it needs is it can't just resolve a host name. www.google.com is called a host name. It can only resolve an IP address. And so it will ask your Raspberry Pi, what IP address is that? Your Raspberry Pi will do one of 2 things. First, it'll look at its own records and say, hey, has anybody else asked for this yet recently? And if so, it'll just return that without ever leaving your network. And so that will be very fast. And then if it hasn't, it will actually go through and it will ask another DNS server, such as Cloudflare's 1.1.1.1 or Google's 8.8.8.8. And it'll say, hey, this guy wants to go to www.google.com. Where is that? And then it will get that request back and then it will hand that back to your device. Then the next time any device on your network requests it, within the timeout time, it will go and say, hey, I've seen that recently, and request it much faster. This can actually speed up your network by a large amount, because one of the slowest things on any network, especially when loading a large web page, is actually the DNS requests. Especially if there's chain DNS requests, you can really speed up your local network by having a DNS server locally that's caching all of these things. And so this project will teach you DNS, which is a crucial component of anything you're doing with a computer. DNS has some awesome features there. It's also going to help with text config, setting up and managing services, having it start on boot and everything like that. Then there's 2 bonuses that I would really recommend people try out, because these are going to definitely get you across the line and get you a lot more breadth in your skills. So the very first one is going to be setting up a replication one. So essentially you'll have a primary DNS server and a replicated DNS server. The old nomenclature for this would be master and slave. And so essentially what this is you will have 2 DNS servers on your network. The reason you want to make sure to have 2 DNS servers on your network is because if one goes down, and if you did not have a second one, essentially your internet's broken. Even though you have internet access, nothing can figure out where to go because it's relying on DNS. So only actually set this on your router if it's either just you and you're comfortable with this stuff on your network, or if you have 2 DNS servers. And so what will happen is you'll have the primary and the replicated. And so that way, if the primary goes down, it'll fail over and go to the replicated one. And these will have to have static IP addresses, and so they will have to always work. But by doing this, you will be able to actually use it for your entire house, because now you've got 2 different DNS servers and they're both used as caching. So that is project 1. And you'll actually set that up in your router to say, hey, instead of telling people to go to this DNS server, I'm going to tell them to go to one of these 2 Raspberry Pi DNS servers. And you do that in your router's DHCP settings. And then the next bonus is actually setting up your own local resolver for certain things. And so for me, I own the domain spacerex.co. And so what I do is I've got a subdomain off that I use for a bunch of local different things. So if I want to go to my NAS, I don't type in the IP address of the NAS, I type in fso1.sr.spacerex.co. I actually have it shortened to just FSO1, but that's a whole different thing. That's a little bit more advanced. But that way, I never have to remember IP addresses. And if anything changes, like I have to change its IP address, I can just do that in one place and everything will update. And so getting comfortable with that is very useful. And so this is a great project to have, where you're actually command line typing in the new DNS addresses, and it should automatically, every single time you update it on the primary, it should automatically be sent to the replicated one. And so if you can do that, you haven't necessarily mastered DNS, but you are very close. And you can pretty much use anything DNS related you need to. And it's very useful to always be using DNS addresses instead of typing in IP addresses every single time that are subject to changing or anything like that. And so those are our first 3 projects. And these are just really useful things to have on your network that actually teach you some really great skills. The next one is going to be a very important thing to remember, and that is to back up. So always back up everything that's crucial. And so we already kind of learned that in the 3rd tutorial, but on this one, we're going to actually be backing up that SMB server we set up in tutorial number 1, or I guess project number 1. And so what this is going to be is the goal for this is to learn scripting, cron jobs, and Rsync, as well as SSH keys. And so essentially what your goal for this should be is, if this is my SMB server that I'm using, this Pi should have a USB thumb drive or even external hard drive if you want a lot of space that automatically gets backed up to every single night. And so essentially what you're going to do is you're going to set up what's called a cron job on the primary SMB server. This cron job is essentially used to execute tasks at a certain time. You're then going to want to write an Rsync script that essentially copies all the change files from here to this, to your backup, and stores them on the flash drive. You're going to want to make sure that this can be done via script, and so for login, you're going to be using what's called an SSH key. And so by doing this, you will be able to not only have a backup of these important files that you've got, but it's also going to teach you scripting. Scripting is a huge part of Linux, and it makes everything so much more efficient. And getting comfortable with scripting and cron jobs is a very important thing about managing Linux servers. Another thing that's huge is Rsync. Rsync is a phenomenal way to copy files over because it is so efficient and uses SSH for encryption. And so it's a really easy way to send a massive backup across a long distance because it just runs really well. And it's got an algorithm that checks to see deltas in files, see what file has changed, and it will only send the changed files. It's not going to send a file that's still on the other server. The bonus for this one is going to be a pretty difficult one, but very useful and very important to think about when you're setting up these services. And that's actually to set up email. So the cron job, if it fails, should send you an email that says, hey, it failed, issue, and actually notify you that the backup did not successfully complete. You also can have it set up where if it does successfully complete, it sends you an email. And so that way, if the entire thing goes offline, you'll notice. That is a really useful thing to have, but is quite difficult. And so now we've gone through 4 projects. And so you should be pretty comfortable typing around in terminal, opening up text editors, editing files, moving around different places, just because you will have had to learn that to go through everything. So now on to number 5. Number 5 is really the bringing it all together to understand how to deploy services that are important. And that's actually to be hosting a giTea website on your Raspberry Pi with a database. And so this is actually going to use 2 different Raspberry Pis. One of these Raspberry Pis is going to be running the giTea website. The other one is going to be running a MariaDB database. MariaDB is a drop-in replacement for MySQL. So FYI, a lot of the things you'll see MySQL with, just use MariaDB instead. It's probably the best thing to do. And so this is going to be not easy, but if you can do it, it is going to be a great task to teach you a lot of different things. One, it's going to teach you how databases work. And if you're standing up websites and things like that, you need to have a at least cursory understanding of databases. The next thing it's going to do is teach you how to set up all these services. When you're actually running the website, the giTea server, you don't want to just download a script that sets it up on their Pi. No, you actually want to go through and follow their install guide and actually enable every single package you need and run everything from there. The other thing that's great is this is a Git server. So people who, if you've not used Git before, Git is a great way to manage code or anything. And so it allows you to manage different versions of code. And so anytime you're writing these scripts, you should be saving them on a Git server. And so that way, if you ever need to grab them again, they're just there. And they've got great different old versions and everything like that. So it's really useful to learn Git. And that's actually why I chose giTea for this. So at the end of this, you should be able to log into a giTea server on here, even have a DNS address for it if you really want to get fancy with task number 3. And essentially this Pi will actually be running the giTea website, and it will be talking to this Pi, which is running the database. And so this is going to be quite advanced because they're also going to be talking, and you need to make sure you've got local permissions where only this Raspberry Pi's IP address plus the username and password are able to talk to the database server here. That's for security. And then you will be pretty comfortable running around in Linux. Now we've got 2 bonuses for this, and the first one I would recommend really doing for everybody if you want to keep going, and that is set up a backup job for the database. So essentially what that is every single night you should have a script that runs on the database and dumps the entire contents of the database to a text document, compresses it, and then sends it off. You could send it off to either a flash drive connected to the first Pi or just another flash drive on here, just in case the micro SD card fails here. But databases get corrupted and it's a huge pain. So that's why you want to do a dump of the database every single night and compress it. And so essentially what you'll do is you'll write a script that automatically dumps all the contents of the table into a text file. So that way, if the database ever got corrupted, you could restore it very easily. Then you'll want to send that off into a different storage medium, just in case the entire micro SD card or flash drive fails here, you've got it in a second place. Finally, the last bonus on this is actually going to be use Nginx to have a reverse proxy setup. So by default, giTea only runs on port 3000. but you want to set it up where it runs on port 80 for unencrypted and port 443 for encrypted traffic. And so essentially what you'll do is you'll set up an Nginx reverse proxy on the Pi itself, and it will automatically redirect the traffic. And double bonus if you can even get a signed SSL certificate. All right, so those are 5 projects that I truly believe can take anybody from I hardly know how to use a Raspberry Pi all the way up to I am now comfortable running around a Linux environment. And going through them is a great way to learn this stuff because a lot of it needs to be self-taught. I'm a big proponent of try out, fail, and do it yourself, and then go from there. That, in my opinion, is the best way to learn. I will be checking the comments, so if you do have any questions, put them there. And then also, any of these tutorials that are very difficult, I will also be making a dedicated tutorial for it, just to kind of get people up and running, because some stuff is huge step ups. If you have any other fun projects like this, leave those in the comments below as well. And I hope this really helped you. All right, have a good one. Bye.